endpoint. I'm going to copy it just to kind of have a good starting point, and we'll make a new file called, we'll call it, I think, just game endpoint. You know what, let's call it trivia endpoint, I think. Yeah, trivia endpoint.dart. So I'm just going to get rid of these right here. We can always go back to the other file to look at them, and we're going to rename this trivia endpoint. Now, the way this is going to work is when the server boots up, it's going to instantiate a class that we're going to make that we're going to just call trivia game. And this is where all the business logic for the game will be living. And this is cool. It's not, we're not persisting anything in a database. It's kind of just this live thing that's going to always be running. And it should be fun. So I am going to, right in my source directory, just make a file. I'm going to call it trivia game.dart. And we're going to create this. So we're going to call something, we're going to call it trivia game. And inside here, we're going to be storing a few values that are going to be changing over time. So we're going to have a list, for instance, of questions. So look, that auto imported. We have the protocol, question, cool, and we'll just call it questions. And we'll start it with just an empty list. There's no questions when this actually boots up. We also want to keep track of what question we're on. So question index equals 0. We'll be starting at, really the first question in the list. We also are going to want to have a timer, and this is going to be used to essentially track, when the round is over and when to move on to the next question. We also want to be tracking at any given time when this round will end. So we'll just start it just as 0, so we don't have to make it null, but that will get updated as soon as we get our implementation in. Lastly, we're going to have a list of players, so we can import player. Now notice a new file didn't come in, and it's because we're importing just protocol, and protocol actually is a generated file that imports all of our models, as well as endpoints and that kind of thing. So once we've imported just this, we get access to all the things we've made, which is really fun. Okay, cool. So now what I want to do is actually make a start function. So this will be asynchronous, but it's not going to return anything. It's just going to really start up the process here. So we'll get that going. And I'm going to go back to my trivia endpoint. And there's other places we could do this. Really this could also just be in our server.dart or our main. But we're actually just going to, when this boots up, we're just going to create an instance called game. And it's going to be equal to trivia game. So we'll get that imported. And then what we want to do right after is actually just start it. So when the server starts, we're going to start our game and we'll be able to access it in here. So what do we want to do in our start function? Well, first of all, we want to load some questions. So we could, make this game with some prefabbed questions that we write out. And when I first made this, that's what I did. I just made very basic questions, that said question 1, question 2. But that's boring and tedious. So we're actually going to talk to an external API here to get some questions. So I'm going to create something called load questions, and we're going to await it because it's going to be an asynchronous operation. And we can just create a method now, load questions, and we'll just make this future void and async. And here we are going to call a URL. This is something called opentdb.com. It's just the first thing I found when I was looking for a place to get trivia questions from. And you can, of course, go to it and check it out. It essentially will just send us back some questions and answers. So let's get that in there. And I am trying to show this once my browser loads. So here's opentdb.com. And if we click on the API here, we can see you can actually generate, how many questions you want, what categories, difficulty, and ultimately it'll just generate you a URL that you can use. Now, I specifically have picked for this multiple choice because I just want it to be, very consistent. And, I think that's all I changed. So we'll see we have that. And it gives you back the URL that you can work with. So now what we want to do is we're going to essentially call this API. So we're going to use the HTTP library because it's actually already part of Serverpod, or it's a dependency of Serverpod, so we don't have to like install it separately. I am getting this warning because it's technically not a package that our pub spec is saying is being used, but so you could just actually install it, but it's fine, it's here, we can use it. So now this is no different than doing something in Flutter, right? I can just go final response equals, and we want to await http.get, and we want to just get that URL, but we have to make it a URI first, so we'll just parse the URL. Okay, then we're going to be able to get the data, so that will just be returning text. So we have to actually go JSON decode and pass in response.body. And here we'll actually get it back. And let's just actually print out what this kind of looks like here. So let's just make sure everything's good. We have our endpoints. Cool. And we'll run our Dart bin / main.dart. And I realized we also, because we've added a new endpoint, anytime you add a new endpoint or change the endpoints, we do have to run this Serverpod generate. So this isn't just for models, it's also for endpoints. Now, if you're just changing the logic within your code, you wouldn't actually have to run this generator. But if you're changing the shape of it, meaning what it's returning or what the parameters are, or even the name, you're going to have to run the generator so that the system knows and it's type safe and everything's good. Okay, so let's go this. And we do have this warning here. I think this is something that'll be patched before the mini comes out. I haven't really looked into it exactly, but it's something to do with some null safety stuff. I realize I do actually want to do this slightly differently because this file I don't think even gets loaded until at least someone makes a request to it. So we weren't actually getting started. So what I'm actually doing is in my server.dart, I'm making a reference to game right here. And then I'm actually awaiting game.start. So we'll be able to access this outside of this file, of course, similar to how you might do something in Flutter with a global key or something like that. So upon doing it that way and restarting the server, we actually get the data back here. And you'll see, I'll try and zoom it a little bit. So we have a list of results in here. It tells you the difficulty, but what we really care about is the fact that there's answers, incorrect answers specifically, and a correct answer. So that's cool. We'll be able to work with that. All right, so now that we have this data, what I want to do is, first of all, we'll have an ID. We're going to start with 0. And we're going to loop through all those results. So we'll call it result in data results. And that's just based on what we've learned from this. And what we want to do is actually, because of the way we've set up our model, where we essentially have all the questions, all the answers in a list, and then just an index. We need to sort of modify this to the way that will make sense for us. So we're going to make a final list of string, call it answers, and it's going to be equal to, and we're going to do a spread operator on result.incorrect answers. And then we want to put in result correct answer, which will just be one thing. Now, of course, if we just did this, we'd always have the last one being correct. So we also want to then just shuffle this so that it's randomized and people aren't just getting 3 wrong ones and 1 right one. Then we need to find out after the shuffle which one is the correct answer. So we can simply just go correct answer equals answers. And we'll just do an index where on this. And we just want to do where answer is equal to result, and we'll take this correct answer. So that'll give us a number of which one, which will come in handy in just a moment. So now what we want to do is we have this questions variable here. So we want to go questions.add, and here we want to construct our own version of a question. So we'll get that ID. The question itself comes from result question. Answers we already have figured out here, and correct answer we already have figured out. So we're good on that front. Okay, you'll see now when we print out the questions and not the data, we have it normalized in this nice way. We have our ID, the question, the answers, and the correct answer, which is the index of what it is. Okay, the next thing we want to do is, because this will be something that is going to just be running kind of ongoingly, we want to be able to start the game and then after a certain period of time, go to the next question. So we're going to set just a constant here called seconds per round. And I am just going to go and ignore for the whole file. I like my consts to be just uppercase like that, just to really define them. Putting this here will get rid of that lovely warning. So now in here, we're going to make use of our timer now. But first, actually, let's set when the round will end. So we want to initiate this, and we're basically going to take datetime dot now, and we're going to add something to that. So we're going to add a duration of seconds, and we're going to just use this value right here. However, we want to now take this and get it to the millisecond since the epoch, which is kind of like a Unix timestamp, except it's actually 1,000 times bigger because it's not seconds, it's milliseconds. So then what we also want to do here is divide by 1,000 to get to seconds. We're seeing an error, and that's because when we divide, it becomes a double. So we'll just round this. So now we know when the game actually starts, the round is going to end in 10 seconds from now. And of course, this is fine for testing. We'd probably make this something like 30 seconds when we're really ready to play. But we can just change it in one spot. Okay, that's great. So we have round ends now. And then the next thing we want to do is actually instantiate our timer. So we're going to make a timer, and we're going to make it equal to timer.periodic. And in here, we'll do a similar thing, duration, seconds, and we'll use that seconds per round right there. And again, we'll take this, and we, inside the callback function, every time this goes, we're going to run a function called next question. And we can make this private because this will be happening all within here. And we will create a method called next question. So our next question, all we really need to do here is take our question index and increment it. Now, for the purpose of this tutorial, we're not going to worry about like a game ending and a new one beginning. We're just going to kind of like loop through all the questions just to make this a lot simpler. So we do want to check if the question index is greater or equal to the length of the questions. We'll go back to 0. So this will just increment, but if it's bigger now, we go back to 0. And then what we want to do is calculate that round ends function again. So we can actually just basically copy this. And we're going to want to now post a message to everyone connected to say, hey, we are going into a new round. But we will do this shortly. Okay, now a couple helpers that I want to put in here. We're going to have just a way to get the game state from our endpoints very easily. So we will go game state. It'll be a getter, and we'll just call it current game state. And here we're just going to return the game state. Now remember, this is that model that we made in our protocol here, which has things like the amount of players or the actual players themselves, the question, and the when the round will end. So here we can simply we'll be able to return players, which we actually don't have yet. Oh, we do. We just didn't name it correctly. This should be a players like that. Question and round ends. So now for question, basically we just want to get essentially questions and then the index. However, let's make a getter for this too, because we might use it in other places. So we'll do this called current question. And here we're just going to return questions at the current question index. So now this can just be called current question. Now we have our game state. Okay, another thing we're going to need publicly available is a way to check the answer. So this will return either a true or false, and we'll just call it check answer. And here we're going to allow passing in the question ID as well as the answer index, which we'll just call answer. So first we want to get the question based on this question ID. And I don't necessarily want to use the current question because, maybe someone just answered it at the last second and the network call was a little bit slow. So I actually want to make sure I get the question that is being checked, not just based on current. And also in the future, we might want to, check other questions, not just the current one for some reason. So we'll take questions and we're going to do a first where right here. However, I would like to use first where or null, which is built into the collection package. So we're going to install that. Dart pub add collection. And this just has a lot of nice helpers for lists, working with lists. So we can actually do first where or null once we have that installed. And what we want to check for is the queue.id is equal to this question ID here. So this could be a question or it could actually be null. In the case that it's null, we'll just go if question equals null. Let's just print something out. Question not found with identifier. And we'll just use the question ID that we passed in. And we'll just return right out of here. Actually, we have to either return true or false, so we'll return false. It's incorrect because we didn't even find that question, so you're definitely wrong. And then all we need to check now, assuming the question isn't null, we just want to go question.correct answer is equal to this answer. So that will either return true or false, true if it's equal, obviously. Okay, awesome. All right, so let's head over to our trivia endpoint, where right now all we have is this hello endpoint. So what we're going to want to do here is we'll get rid of this. And we're going to create a few methods here. One of them will be the stream opened, which is just an override of something that exists on endpoint. And this happens anytime someone connects via socket. So not an API call, but actually connecting via socket, which will probably make more sense when we get to the Flutter side. So what I want to do whenever someone connects is we're just going to run send stream message within our session. And we're going to take the game, which we have to import. So there's our game, and that came from right here, just kind of like the singleton here that we instantiated. We want to do game.current question. So this will actually stream when someone connects the current question to them so that they can have it right away. And then we also want to set up, instead of doing this, essentially a listener here where anytime that this channel, which we're going to fill in a minute, has an event, it'll go and send that stream message to them. So we need something to hold our channel name. We can call this anything we want, but it's definitely a good practice just to have a constant for this so that you're not retyping the same thing. So we'll just call it trivia channel. And we'll do that. And we need to just make sure this is asynchronous to conform to the shape that we're supposed to have here. So we'll have that when the stream is opened. Now we also want to do an override on handling stream message. So anytime a stream message comes in, this is where we can do things. Now we'll also make this async, and I'll just put a to do here to handle messages. And the reason for that is we're not going to even worry too much in this tutorial about the client communicating through a socket. We'll be more broadcasting stuff to them, whereas the client will be actually just making more traditional API calls to actually interact. However, there will be a point at the end, kind of like the bonus chapter of this tutorial, where we will actually see how this works. So I'm just going to put a nice to-do there. Okay, so let's make some actual normal endpoints. So these are just like an API endpoint, a RESTful call. And we're going to make something that is going to allow a player to join the game. So we're going to just call it join. And if you remember from earlier, we need to always have session as the first parameter. And then we're going to require a name to come here. We're going to make this asynchronous. So our clients will be able to call the join function and pass in a name, and the server will do some things. Now we want it also to return something to them. And what it's going to return is a player, not a platform, a player. Because we want to sort of auto-generate, although they'll be passing the name up, we want to auto-generate their ID and maybe some other things. So we need to return to the client, hey, this is you, basically. So to do this, first of all, I'm just going to make a quick new file, and this can just go in our source of our server called utils. And I'm just putting in this thing that I use in many of my tutorials, just generate random string. So this will use the random function using any of these characters and essentially return a random string for us. So that's what we can use now, and we can actually create this identifier. So when someone joins, we'll just call identifier, and we're going to use our random string, and maybe we'll make it 16 characters. And then we'll construct our player. So player is going to be equal to player, and we're going to pass in identifier, we're going to pass in name, and we're going to pass in their score. Now their score will be 0 when they start, which makes sense, but that will change over time. And then we're going to want to add them to our game. So we'll do something like add player, which we don't have yet, but I'll have it ready for us. So we'll add the player to our game, and then we're going to want to return the player. So let's do the adding of the player now. So we'll go to our game again, trivia game, and maybe right here, we're going to create something called add player. So this will be pretty simple. It'll be void, it doesn't need to return anything, and we're going to call it add player, and we're going to expect a player to be passed in called player. And all we have to do now is take our players, and we'll actually just update it by spreading whatever's currently in there and adding this new player. So now when we call this, it's going to be part of this list right here. So we add the player, cool. And then something else that's important that we want to definitely do here is we want to post a message to all the other players. So we can go session.messages.postMessage, pass in the channel name, and the message we want to pass is just the current game state, because the game state has actually changed. Part of our game state are the players. So something's changed here. Let's post it. Let's send it along the way so that the client can actually update, who's in the game. Okay, so that's our join function. We're also going to want something where, potentially when the player joins or they rejoin, to be able to at any point get the current game state. So we're going to create another method that returns the game state, and we'll just call it like get game state. Passing in session again. Now this one won't have any parameters, but it will be asynchronous. And we are going to return game.current game state. So that will just give them back this. That way our client can ask, hey, I don't know what the game is doing right now. Can I have it? Cool. There it is. Then I think lastly, we need a way to submit an answer. So this will return either true or false, so we can tell them if they're correct or not. We'll call it submit answer. And here we need to, of course, have the session to be passed in as normal. And we're going to get the client to pass in the player identifier. That's their unique identifier that we generated up here. And they will know it because they got it back when they called this function. We want them to pass in the question ID that they are trying to answer and their actual answer that they passed, which will be the index, basically. So here, we'll first check if it's correct. And we already have a way to do this, right? We can go game.checkAnswer, which is that function we made a few minutes ago, passing in question ID, passing in answer. And here we can go if correct. We can actually do something to their score. So let's say game.updateScore. And here we're going to pass in the player identifier. And we're going to want to add 1 to it in this case, which I know this doesn't exist yet, but we'll get there in a minute. And we'll just return true after this. Otherwise, we'll return false. They got it wrong. So let's make that update score function now. So let's do that. I think around checking the answer makes sense. So this will be a void function, update score, where we pass in the player identifier, and we'll have something like maybe called amount. And in here, we need to find out who that player is. We have this list of players here. We want to actually know which one it is based on the player identifier. So what we're going to do is we're going to get the index of that. Player index is equal to players dot index where, and we'll just call this P, and we'll say where P dot identifier is equal to player identifier that we passed in. Now, if the player index is less than 0, because the way index where works, it will give you the index in that list, 0, 1, 2, 3, whatever. However, if it doesn't find it, it will return -1. That's how the index where works. So if it's less than 0, meaning it didn't find anyone, we can essentially go print, and this is really just for our purposes, player not found with identifier, and then we'll just do the player identifier, and we'll return out of this and won't do anything. In the case that it does work, what we'll do is we'll make an instance of this player, we'll get the player. So we'll go players, and then at that player index, we have a player. And then we're actually going to update something about the player. So we can go player equals player.copyWidth. And copyWidth, something that's great about Serverpod is it comes baked in. It's one of those generated functions in here. So we can have our copyWidth, and we'll just take our score, and we'll take the player dot score, so whatever it is right now, and just add 1 to it, or actually add amount to it, because in theory maybe some questions are worth more points. So we'll want to add that. And now what we want to do is actually just go to our players at that player index and replace it with this again. There we go. So let's save that and make sure that our update score is now there. Okay, cool. So that's most of our stuff here. The one thing that I'd like to do now is we have this to do here that we should probably take care of. So what I want to do here is essentially broadcast a message, and similarly, we can do something, like session.messages.postMessage, like we've been doing before, get that channel name, which we'll just import in, and then we'll want to pass it through the current game state. But you'll see we don't actually have access to session here because we're not actually within an endpoint. The good thing is, though, this is something we can get access to, without actually being in an endpoint. It just takes a little bit of extra code. So to do that, what we will do in our constructor, which we don't even have yet, so let's make it trivia game. So when this constructs, we're actually going to go serverpod dot instance, and we're just going to go create session. We can turn on logging, sure, enable logging, true, and then once it's done, we'll have an instance of what's called our session here. I'm just going to keep it as value because I actually want to make something up here, and I'm going to move these actually underneath the constructor because these aren't really like required parameters, final parameters. So I just like this pattern, but we are going to have something called late final session. Just call it session, and right here we will just basically go session equals value. So this is something you could, in most cases, do with an await. However, in a constructor, you can't make this asynchronous. So we have to kind of do it the not as clean way by running it, then doing a then and passing it. So we're just doing session equals value, and that will set this session up. That way down here now, if I actually type this correctly, session.messages, we actually have access to the session and we can send this off. So let's get rid of that. Okay, other than maybe some small tidy ups that we need to do, first of all, well, let's run our generate. So serverpod generate, because I do see there's like sort of an error here. And that's because it's probably looking for that hello endpoint that no longer exists. So there we have it. If we go to our problems, nothing, just some little warnings, nothing bad. So I think we're good. So we're going to move next on to the front end of this and probably come back and forth a little bit to here, but this is mostly, I think, what we'll need for the back end to make this work.